Atmospheric pressure. Books on meteorology often describe Earth's atmosphere as a huge ocean of air in which we all live. The part of our atmosphere that sustains all life that we know of is, in reality, exceedingly thin. An important property of any gas is its pressure. The atoms and molecules that make up the various layers in the atmosphere are constantly moving in different directions. Despite their tiny size, when they strike a surface, they exert a force on that surface in which we observe as pressure. Density and air pressure changes with different altitudes. So how does atmospheric pressure relate to our daily weather patterns? Weather forecasters show the weathercaster making reference to high pressure and low pressure systems. What are they talking about? Pressure varies from day to day at the Earth's surface. Unequal heating from the sun causes temperatures to vary over the entire globe. Air at the equator is much warmer than at the poles, so the warm, light air rises and spreads towards the poles, and the colder, heavier air sinks towards the equator. This simple wind pattern is distorted due to the fact our planet rotates. Air is twisted to the right of its direction of motion in the northern hemisphere and to the left in the southern hemisphere. This is called the Coriolis force. Great wind spirals are produced, which we know of as high and low pressure systems. In the northern hemisphere, the air in low pressure areas spirals, counterclockwise and inward. Hurricanes circulate air counterclockwise. In contrast with high pressure systems, the air spirals clockwise and outward from the center. In the southern hemisphere, the direction of the spiraling of the air is reversed. So why do we associate high pressure with fair weather and low pressure with unsettled weather? High pressure systems press down, which low pressure systems are akin to atmospheric valleys, where the density of the air is less. Since cool air has less of a capacity to hold water vapor, as opposed to warm air, clouds and precipitation are caused by cooling the air. So by increasing the air pressure, the temperature rises. Underneath those high pressure domes, the air tends to sink into the lower levels of the atmosphere, where temperatures are warmer and can hold more water vapor. On a weather map, you will notice a blue H showing the location of a high pressure system. Any droplets that might lead to the formation of clouds would tend to evaporate. The end result tends to be a clearer and drier environment. If we decrease the air pressure, the air tends to rise into the higher levels of the atmosphere, where temperatures are colder. On weather maps, a low pressure system is labeled with a red L. As the capacity to hold water vapor diminishes, the vapor rapidly condenses and clouds, which are composed of countless billions of tiny water droplets, or at very high altitudes, ice crystals, will develop and ultimately precipitation will fall. Meteorologists could not forecast zones of high and low pressure without employing some sort of device to measure atmospheric pressure. How do we know what the pressure is? How do we know how it changes over time? Today, electronic sensors in water stations measure air pressure. Barometers are scientific instruments that are used to measure atmospheric pressure. Meteorologists use barometers to predict short-term changes in the weather. A barometer measures atmospheric pressure in units of measurement called atmospheres or bars. An atmosphere, ATM, is a unit of measurement equal to the average air pressure at sea level at a temperature of 15 degrees Celsius or 59 degrees Fahrenheit.